Hello everyone, I am Rashad and today I am going to talk about the abstract in our experiment. The specific growth rate is a key control parameter in the door yeast. In this experiment we are going to show the yeast and how it's going to active in different temperature and different times. By this experiment, we will find the size of door expanded when exposed uh, when exposed to under certain environment and time. This experiment will show us observe the growth of cyclicism gravity, a yeast strain. When purpose a method to standardize the growth of yeast with respect to an initial size of door. This experiment will have three different condition, which is room condition, dark room, and under sunlight. We find that experiment give us deep understanding of the mechanism of the yeast and how statistics data help us to study the growth of the yeast. Okay, now we are going to experiment protocol. Our material is the water, flour, yeast, and egg. Appears um, six same size container mixture, stirry, measuring cylinder, scholars. Our procedures is the first one is prepare the material and appear it above. Put 1.2 kilogram flour, 2 cup of water, and yeast and egg into the mixture and mix it for 5 to 10 minutes to get the well mixed protein on of dough for the first batch of the experiment. Measure the mass of dough at least 200 gram per dough and separate them into different containers. For the first experiment, put the dough under different environment which are in room condition, in dark room container, and expose it under sunlight for 35 minutes. For the second experiment, put the dough under different times, which is 20 minutes, 25 minutes, and 30 minutes under room temperature. Record the initial height for door by marking the container side to define initial and final heights. You use the ruler to measure the height of the door raise by looking at the point marked. Record the change in heights of door on the table prepared. Repeat the experiment for the second, third, and fourth batch.
Assalamualaikum warahmatullahi wabarakatuh. So today I am going to explain about analysis of our experiment. So in our experiment we have two experiments. Firstly, experiment 1, the height of dough increase at different environment. So here we constant the time interval at 35 minutes and we change the room condition, first, which are the room condition, dark room and under sunlight. So we repeat each of the condition 4 times with four batch, and we constant the initial height at 2 centimeter for each batch. So here we gonna calculate the final height. We observe the final height of the yeast after 35 minutes. So lastly we minus the height so we can get the change of height in cm. So for experiment 2, the height of dough increase at different time interval. In this experiment we maintain the room temperature at 24 degrees Celsius and we change the time interval at 20, 25 and 30. And then we repeated this set of time interval 4 times. Okay, so this gonna be batch 1, batch 2, batch 3 and batch 4 because we repeat this experiment 4 times and same as the previous experiment. We also maintain the height of the yeast with 2 centimeter for each batch. And then we, after each time interval, we record the final height of the batch and then we minus final minus initial, we get the change of height in cm. So as for 25, we need to wait after 25 minutes and 30 minutes. And then we repeat the time interval for 4 times. Next, this is the growth rate. The growth rate of yeast we need to calculate. This is for the different time interval. We maintain the room temperature at 24. And then we calculate the mean change of height at 20, 25 and 30. And after that, we calculate the growth rate of yeast. So from here, we can conclude that when the time interval increase, the growth rate of yeast decrease. But the mean change of height increase. Okay. So next, we plot the graph. This graph is for both experiment 1 and experiment 2. This is for experiment 1 and this is for experiment 2. Here, we can clearly saw that the height raised by the yeast under sunlight is the highest, while for experiment 2, the height at time interval 30 minutes is the highest. So we can clearly saw the data here. Same goes for experiment 1. Okay. As for this graph, this is for both experiment. For graph 1, for experiment 1, this is the calculated growth rate. So we also can see here that under sunlight, the growth rate is the highest, and at room condition, the growth rate is the lowest. This is by calculated with the data and time interval that we set before. And for graph 2, it shows that at constant temperature but different time interval. So here we have 20, 25 and 30 minutes time interval. So we can see here that at 30 minutes time interval, the growth rate is the highest, and at 20 minutes time interval, the growth rate is the lowest. So for data,
The degree of freedom for between groups we must calculate by total number of group minus 1, where is 3 minus 1 we get 2, and within groups the formula for degree of freedom is the number of trial minus the groups, where the number of trial is 12 minus 3 we get 9. So the total of degree of freedom here is 11. To calculate the mean square, we must divide the sum of square by the degree of freedom for both groups. So we get between the group have 2.56, while for the within groups we got 0.04778. And finally, we are going to find this value, which is the ratio between group and within groups. And we got here is 53.5814. From here, we need to find the F grade from the graph, from the table that have degree of freedom between groups and degree of freedom for within groups. And we got the F grade. We can deduce that if the ratio is bigger than the F critical, the null hypothesis is rejected. For the experiment 1, the null hypothesis for this experiment is the all of their mean for the respective groups is equal. But here we can see that the F grade is lower than the F. So from this calculation we can deduce that the null hypothesis for this experiment is rejected. The p-value here we generate using the computer, where we got the p-value is 1.003 to the power of -5. The way we read the bell-shaped table that have alpha is equal to 0.05, where it is shaded at the right side, show that if the value of p is inside the 0.05, the null hypothesis is rejected. But the groups here we change it into 20 minutes, 25 minutes and 30 minutes. Therefore, the ANOVA result for this experiment have different value. Firstly is sum of square for the between groups is 0.945, while within group have 0.325. Degree of freedom for the within group is 2, where the formula is number of group minus 1, where the number of group here is 3. 3 minus 1 is 2. And the formula for within groups is number of trial minus the number of group, where the number of trial is 12 minus 3 is equal to 9. So the total number for degree of freedom is 11 here. For the mean square, we divide for both between group and within groups with their respective degree of freedom, and we got the mean square. For between group is 0.472825, and for the within group is 0.03611, and we find the ratio of it is we got 13.05, sorry, 13.0846, and finally we create from the table, and we got for the row is 2 and for the column is 9. So we got the F grade is 4.2565. From here we deduce that the null hypothesis for experiment 2 claim is being rejected. It's also being proved that the p-value of this ANOVA table have lower value than alpha. That increase the evidence that our data our hash null for this experiment is rejected.